So we're going to go over a quick example of some types of problems in section 8.5. We're graphing quadratics in the form of ax squared plus bx plus c. And we do need to understand this is just part one of this. This is only going to work for factorable trinomials only. There'll be some other examples where they are not factorable. So here's our example for today. We need to graph the quadratic function f of x is equal to x squared plus 6x plus 8. And the way that we do that is by following this list of steps in order. So the first thing is finding the x-intercepts. And the x-intercepts are nice and easy to find because we know that the x-intercept has the output value, or in other words, the y value, is 0. So we can take our function, f of x, which is equal to x squared plus 6x plus 8, and since we're looking for the x-intercepts, we know the y value has to be 0. So we can take that output and set it equal to 0. So we can ask ourselves what x value would give the y value to be 0. So we're going to use some factoring. So we do notice that the leading coefficient is a 1. So we're asking ourselves what numbers would multiply to 8 and add up to positive 6. And those numbers are positive 4 and positive 2. So now we can use our zero product property. If we're multiplying things, one of those factors must have been the reason that we got 0. So we set them equal to 0, and we could see our two x-intercepts will be at the x value of negative 4 and the x value of negative 2. Now, since they are points, we know the y value is 0, so we're going to write them as points. We're going to go over here and graph them. So here's negative 4, 0, and here's negative 2, 0. Next, we move on to the vertex. And the reason that we're moving on to the vertex is because we know that the vertex is halfway in between the x values. So the x value of the vertex, as we wrote down in our notes, we would add the x-intercepts, so negative 2 plus negative 4, and then divide that by 2, which gives us negative 6 over 2. So the x value is negative 3. But we need to find the y value. So to find the y value, as it said in our notes, we are just going to plug that in to the original equation to find the output. So I'm going to do that up here. So if I took the number negative 3 and plugged it into our function, I would take that number and square it. I would add 6 times that number and then add 8. So this gives us 9 minus 18 plus 8, which is negative 9 plus 8, which is negative 1. So our output is at negative 1. Now the axis of symmetry is just a vertical line, so we're going to draw that in first. We know the axis of symmetry cuts the parabola in half, and it always goes through the vertex. So the x value of this line, well, if the vertex is on it, the x value must be negative 3. So the axis of symmetry is the line x equals negative 3. Next, we're going to move on to our y-intercept. We know our y-intercept, we know that x is equal to 0. So for our y-intercept, I'm just going to come show some work over here. Again, we know that x is equal to 0. So I'm going to take my function, and I'm going to plug in the number 0. So I would take 0, and I would square it. I would take 6 times 0, and then at the end add 8. So we would get 0 plus 8. So if we plugged in 0, we'd get out 8. So again, if we put in the x value of 0, we'd get the y value of 8, and that is our y-intercept. Now the last part is the symmetric point of the y-intercept, and as we talked about in class today, we know that any point on a parabola is the equal distance away from the axis of symmetry. So we can see that. Let's just zoom in on our x-intercepts. We know that this x-intercept had the x value of negative 2, and this x-intercept was the x value of negative 4. And our axis of symmetry right here is the x value of negative 3. So between negative 2 and negative 3, that's a distance of 1. And between negative 2 and negative 4, that's also a distance of 1. So partner points are the same distance away from the axis of symmetry. So the y-intercept also has a partner point. And all we need to do is figure out how far away is the y-intercept and travel that same distance on the other side of the axis of symmetry. So our y-intercept has an x value of 0, and again, our axis of symmetry has an x value of negative 3. So this distance is 3 units. So its partner is going to be 3 units away on the other side. Now what we know is we started at the x value of 0, right here. We added 3, so this x value is negative 3. We went another 3, so that x value must be negative 6. And we know that partner points have the same y value because we didn't go up or down at all. So if the y-intercept was at 8, just moving left and right, my y value is still at 8. Our last step is to finally just connect the dots in a U-shaped pattern, because we know that all parabolas make a U-shaped pattern. And as we can see here, our plot is correct because we make that U-shaped pattern.